everyone. If this is the first time you visit my channel, thanks for being here and welcome to my channel. Have you wondered what is the difference between type 1 and type 2 diabetes, or why do we need insulin? Well, today's video will offer you a portion of one of my lectures talking about diabetes and the role of insulin and glucagon. You know already that glucose is a monosaccharide and is a carbohydrate that our brain uses as a source of energy. So to maintain the function of your brain and your body in general, you should keep your blood glucose levels between 70 and 100 milligrams per deciliter. Of course, these values fluctuate because right after a meal, the glucose levels will increase very quickly, depending also on the foods you eat, and then your body will try to reduce these glucose levels to go to normal conditions. So when you have higher than 100 milligrams per deciliter, we refer to this as hyperglycemia. However, if you are fasting or things like that, you spend too much time with no any intake allowing you to get some glucose, then you will go below 70 milligrams per deciliter, and this is known as hypoglycemia. And most of you know that both cases, the person will have some kind of reactions in the body, blood pressure, etc., will be affected depending on the problem, hypo or hyperglycemia. So the goal for your body is to try to keep this into a normal range. And how your body do that? How your body try to reach the right values? Well, the liver first is the organ that tries to keep the glucose levels by doing some processes like breaking down of glycogen to give you the glucose that you need, or synthesis of glycogen to store this glucose if it's too high for later use. But then this is also favored by two hormones secreted by the pancreas. So insulin and glucagon. Let's talk about insulin first. As you can see here, insulin is released when glucose is very high. So when we go above 100 milligrams per deciliter. So an insulin acts as a messenger to your body. So for high glucose levels, the pancreas will respond to this by secreting some insulin, and then the secretion of insulin will act as a messenger to your body. And this message in insulin is like, glucose is too high. That's something that can happen after a meal. Let's try to remove this glucose from our system. And the way this can be done is by synthesizing glycogen. This is done as glycogenesis, because it's a creation of glycogen. And this is a way for your body to take glucose out of your blood. In contrast, if we are going below 70 milligrams per deciliter, it means too low, so that could be dangerous for your body, then the pancreas will secrete glucagon. So they act as opposite hormones with opposite roles. And glucagon will signal, okay, the blood glucose level is too low. Let's do something. For example, the breaking down of bonds in glycogen that you have in your muscles and in your liver. So this is called glycogenolysis, because it's the breaking down lysis of glycogen, so that we can take glucose from this just to increase the blood glucose level. By the way, glycogen is synthesized or is stored in the muscles and the liver. So glycogen in your muscles, in case we need it, will give us glucose. Glycogenolysis will give us the glucose we need for the function of our muscles, for walking, etc. And the breaking down of glycogen in the liver will give us the glucose that we need for keeping the right blood glucose levels and then maintain the function of our brain. Talking a little bit more about this, right after the meal, for example, in normal conditions, your blood glucose levels will increase. And then the way for your body to respond to this is to remove this glucose from your blood. And this is done by secretion of insulin. So high blood glucose levels from the liver coming from diets, for example, will go to our blood will go to our blood, and then insulin here will be secreted by the pancreas, and insulin will act by different ways. One way is that it stimulates, as you can see here, it stimulates the increase of transporters of glucose, so that glucose can be taken out of the blood to the cells that need glucose. And another way is to stimulate the synthesis of glycogen. So too much glucose, let's store it for later use. And another way, if we don't need more glycogen, then we can store this glucose as fatty acid. So any excess of calories in the form of carbohydrates is stored in the form of lipids or adipose tissue. So summarizing, insulin stimulates glycogenesis, it means synthesis of glycogen, and it also stimulates synthesis of fatty acid. And this is a process called lipogenesis. And all together is done just to remove the glucose from our blood to keep the right glucose levels. How you can remember which one is the hormone that is released in high or in low glucose levels? Just think about the letter I. So insulin contains the letter I, like in high. So insulin is released when glucose levels are high, and glucagon contains the letter O, like in low. So glucagon is released when the glucose levels are low. So that's what happened in normal condition. What happened in diabetes is this system, the response or the release of insulin is broken somewhere, somehow. And then that way glucose levels cannot be regulated, and then the amount of glucose in our blood stay very high. By the way, about 26 million people in Americans have diabetes. Depending on the molecular factor that affect this system, diabetes is classified in two types, type 1 and type 2.
Okay, what happened in type 1 diabetes is that once the glucose is released into the bloodstream, these are supposed to be taken by our system with the release of insulin. But in this case, the cells of the pancreas are unable to release insulin into the bloodstream. In the absence of insulin, then the glucose is not taken up by the cells, and as a result, there is an increasement in the levels of glucose levels. And therefore, these people require daily insulin injections and blood glucose, and monitoring their blood glucose levels. This is a type of diabetes that usually starts in childhood. So as a result of this, so there is no messenger to tell our system, okay, let's remove insulin by creating glycogen or by storing this in the form of fatty acids, etc. In the case of type 2 diabetes, what happened here is the same. Well, the liver will release the glucose into the bloodstream. The cells of the pancreas in this case are able to release insulin into the bloodstream, but the cells do not respond to the presence of this insulin. And the result at the end is the same. So glucose remains in the bloodstream. And also another thing that will happen in this case is that as the glucose levels remain high, the pancreas will think that we need more insulin. So progressively higher amount of insulins are produced to stimulate the uptake of glucose, but nothing happens. And this will have other impacts in the health of the patient. So in both cases, as you see, high levels of glucose remain on the bloodstream. So this picture is showing you the normal condition, what should happen. What happened in type 2, type 1 diabetes is mainly that insulin is not produced. In type 2 diabetes, insulin is produced, but the cells do not respond to the presence of insulin. And at the end, all the processes that are supposed to start after the uptake of glucose are not happening.
I just want to call your attention that in today's video, we were talking only about insulin and glucagon, the role of these two hormones. But there are 4 other hormones, and I'm sharing with you here and here, that are also involved in the regulation of blood glucose levels in our cells. Again, this was just a simplified view for an introductory course on human nutrition, and I hope this information was useful for you. Thanks for watching. Please press the like button or subscribe to my channel.